Hi everyone, let's look at problem 3 today. Longest substring without repeating characters. Given a string S, find the length of the longest substring without duplicate characters. Okay, so we are given string S and we like to find the longest substring without repeating characters. I think I understand the problem. Let's look at some examples. First one, we have A, B, C, A, B, C, B, B. So here it looks like the repeating character is BB. So if I take 1, 2, 3, 4, 5, 6, I think I can take the first 7 character. Alright, I'm wrong. The answer is ABC with length of 3. Okay, so I assume that it means we cannot find a repeating character. Alright, I read the question wrong. I thought it was saying adjacent repeating character. Oh wait, it actually says longest substring without duplicate character. Okay, that makes sense. Example 2, we have B, 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 B. Now this will return 1. And the third one, P, W, W, K, E, W. Output. So we can take PW or W key E or key EW. So return should be 3. Yep, WKE with 3. Notice that the answer must be substring. PWKE is a subsequence and not a substring. Okay, so subsequence is PWKE. Substring. Alright, I see. Substring should be a slice of a string, but subsequence could be could pick anything that is in order. So I'd like to ask a clarifying question. First one is length of S. So may I know whether the string S has at least one character? So here it says no. The string length is between 0 to 5 times 10 to the power of 4. And the S consists of English letter, digits, symbol, and spaces. Okay, here I would say I like to have another clarifying question. Can I assume that I can use any character in my substring? Say that substring can be space. Let's say it can be any character, i.e. space. Let's just assume it's yes. So let's look at this problem here. Okay, so I can think of one way off the top of my head. We could use a set, and then we try to maximize our window size as we move along the string. So we start at the beginning, and then we move on to the next character. We add it into our set that we pick up. And as long as it's not repeating, we will keep on picking up new character as we go along the string. But once we find out a duplicate character, then we start removing our set from the left index. So we minimize our window so that we could pick up the current character, meaning that we downsize our window size in our set until we found the character that you would like to add right now. Okay. Then this would then allow us to further maximize our size of our set, our substring, as we move along again toward the rest of the string. I think this should work. Maybe let's go through the example. And with the current questions of whether the length is larger than 0, here I like to add a test case where the string is empty. Okay, so let's look at the first example. We have A, B, C, A, B, C, B, B. So first of all, we will have A, B, C, and then we would then encounter an A, so we decrease our window size to BCA. Then we encounter a B, so we take only CAB this time, and then we encounter another C, so we take ABC. Then there is a B there. So what we can do is we take the B. Well, actually, we just can move on to the C directly. So we got CB. Then the next is B, which is can only be itself. So this seems to work. I mean, the logic seems to work. The second example, we have 5B. So first of all, we have B, and then we have B, 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 B. Then here we see that the maximum substring that we can take is 1. For the third example, PW, W, K, E, W. For the first one, we could take PW, and then we need to remove everything until we get to the WKE, and then in the end we have W. Alright. And remember the fourth one is just 0. So I think this should work. First of all, we try to maximize our substring, but as soon as we encounter a duplicate character, we start to minimize our window such that there won't be any duplicate. if we include the current character. Okay. Does this sound reasonable to you? I'd like to start implementing this, unless you'd like me to further explore the optimization. I think this would have a ON time and the O1 space, because we don't need any additional space. We are just going through the string once. Okay, so first of all, I will need a set. So I'm gonna call it substring. Then I will go through the string, but first of all, I need to indicate the window size. And it's better to just use a left and right. So here I will left and right pointer. So the left one would be 0, and then the right one I'm gonna use it inside our loop. So for r in length of sub and length of s, then I'm gonna check if the current character in substring, then what I'm gonna do is I'm gonna keep increasing. Because I might not encounter the character to drop out using a single in the first iterations, I'm gonna use a while here. So while s of r is in substring, gonna increase the r. Wait, let me think. I'm gonna remove the left one. So substring dot remove the string of the left index, and then left minus equals 1, and plus 1, so I keep moving to the right side. And then at the end, once the current substring is not in the substring, I will add it back. Substring dot add s of r, and then the max, I'm gonna call it max. The max of max and right minus left plus 1. Okay. Of course, at the end, gonna return the maximum substring size. So I think this should work. Let me quickly walk through the code to make sure I haven't missed anything. First of all, I'm gonna create a substring set, which is the set of characters that I have seen so far. I'm gonna use 2 pointers, left and right, to indicate the substring, the left index and right index of the substring that I'm gonna pick up. Then I will look through all the characters, and as I do so, if I found a duplicate character, Then I will start removing characters of the left pointer until I could pick up the current character. So that means that I am trying to not have any duplicate while also maximizing my substring size. Then in the end, I'm gonna include the current character in our substring set, and I check the maximum length that we have so far. Okay. I think it should work. Now let me test the code with the input example to make sure they run as expected. So first example ABC, ABC, BB. Then first one we will have A. A is not in the set. Let me write it down. One is A, B, C. A, B, C, B, P. Now I'm gonna have A, B, C. Then I am gonna remove it until we have BCA, and then CAB, ABC again, then CB, then at the end it would be a B. So that would give us, at that point, we're gonna have 3. In the second example, we have B, 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 B. So B, B, then remove it, include again, remove, include, remove, include, remove, include. So the maximum for the second example is just 1. And the third example, PWW, KEW. Firstly, we will have PW, then we will have W, WK outside, RLKE, and then KEW. Right, I think this should work. Let me try to put it into the LeetCode platform. Hopefully we got it right. Substring. Do I even need the set? Yep, I do. So substring equals set left is 0, max is 0. Therefore, R in length of S, gonna call while S of right in substring. I'm gonna remove it as dot left is equals 1. Then gonna edit the current right one into, and I forgot that this should be a range. Substring.x says of R. The maximum would be the max of the current length compared to the previous maximum. Let me try to run it. Hopefully it's correct. Wrong answer. Because we forget to return our solution. Okay. Yeah, got it correct. Let me try to submit it. Okay, that is pretty efficient. Let me see if there is a better solutions out there. So this guy is not using any set at all. So how does it know? Right, it's using a string, but it's basically the same concept. Let me look at some more examples. This sounds like the same thing that I'm doing. Okay, so let's look at this solution here. We have previous of C decreased by 1. Line is current length of I minus precious of I. Okay, so this might be much more efficient because instead of moving the left pointer one by one, in here it stores the where such character is. Okay, interesting. So once we know the position, we could just directly move the left pointer to right after the position that we have recorded. So there's obviously a bit more efficient, I would say. It's still all in time, but it does give you much more efficiency. So I guess that's about all the resolutions that I have seen so far. I guess we will end here in this video. Let me just quickly take a look at some of the examples. Yeah, I think everyone is doing the same thing. So thank you everyone. Let's end the video here.